Welcome to In 5 Minutes. Now we'll study a new concept, structures and pointers. Now we know what our structures are, user-defined types, which hold multiple variables of same or different types, and pointers are the variables which hold address of other variables. Now, as we can have pointer for int or float, same way we can have pointers for even user-defined types like structures also. So now let's see a demonstration of how we use structure pointers. Now commonly we define a pointer by using syntax data type star name. Name is the name of the pointer, star is just to indicate it's a pointer variable, and data type is any type of C, which can be a primitive type or it can be even user defined type. Now let's see an example with structure. Suppose in a program we have defined a demo structure data type with A and B as members, so this becomes a user defined type. Now using that type we can define a simple variable by writing structure demo s. So this defines a structure s in memory. Suppose the structure is defined at some memory address 1000. So 1000 onwards there are 6 bytes taken by structure demo variable. Why? Because there are 2 byte integer and 4 bytes float over there. So there is A and B variable inside it. Normally we can access the members using as.a or as.b syntax. Now I want to make a pointer for the structure. To make a pointer for any data type, first you have to define a pointer of that type. So here I'll define a pointer by writing struct demo star p. Now when you write a simple statement like int star p, it stands for p is a pointer for integer variable. So p can hold address of any integer. Same way here you have defined p as a pointer. I'm just drawing for demonstration. P you have defined as a pointer that can hold memory address for structure demo. Currently p has no value because p is just defined without any value. But look at the statement again. P is a pointer variable for structure demo. So p can hold address of any structure demo variable in memory. Now I wanted p to hold address of s variable. So I can write over here p equal to address of s. Because of that, address of s, that is 1000, will be stored in p, and p refers to structure s. Now structure s is not a single variable. Structure s itself is a variable made up of multiple variables, in this case a and b. Now to access members of structure using pointer, we have a special syntax. The syntax is we write pointer arrow, that is minus sign greater than sign member name. So whenever you want to access a member of a structure using pointer name, we have to write it like this: pointer sign, then arrow, read as arrow but written as two symbols. Actually it is minus sign and greater than sign put together, and then we write member name. So if I want to work with the members of the structure, in this case I can write p arrow a or I can write p arrow b. For example, I want to assign a value 10, I can write p arrow a equal to 10, or p arrow b I want to assign suppose 2.5, I can write p arrow b equal to 2.5. By this statement we are putting a as 10 and b as 2.5 for s. Actually this statement is equivalent to, we are putting s dot a equal to 10 and s dot b equal to 2.5. To access members using structure notation, we can use structure name dot member name, but to access structure member using its pointer, we have to use pointer name arrow member name, that is p arrow a and p arrow b. Otherwise what are operations you have to do, that is inputs, outputs, increment, decrement, all operations we can perform using this same syntax using pointer notation. So in this case p arrow a will store value 10, so there will be 10 stored in a structure referred by p. Same way p arrow b equal to 2.5 is actually read like store 2.5 in a b variable referred by p. So there will be 2.5 stored into b. I'll read it again. P arrow equal to 10 stands for put value 10 into a variable a in a structure referred by p. Same way p arrow b stands for put value 2.5 into b variable in a structure referred by p variable. So like it's a of s, it is a of p referred by pointer, or it is b of p referred by pointer. So we can use this syntax or this syntax to access the members of structure, But if you have pointer, we have to use this notation. If you have structure variable, you can use this notation. In this case, actually, we already have s variable, so we need not actually use the pointer variable. But here for demonstration, we define the structure, then we define the pointer for it, and then we have seen how to access members of structure using pointer variables. Thank you.